Point 6, we're going to learn another shortcut called the chain rule. This is for a specific type of function. So first we're going to start by writing out the chain rule, and then I'll go back and kind of talk you through what's happening here. Try to explain it in a few different ways. So if y is equal to f of u is a differentiable function, of u, and u is g of x is also a differentiable function, of x, then you'd see make that substitution. If u is g of x, then here we get f of g of x. So y is equal to f of g of x. So this is also a differentiable function of x. And we can say the derivative of function y with respect to x is dy du times du dx. So this is what we have up here. Derivative of y with respect to u times the derivative of function u with respect to x. This is one way to write the chain rule. Or we can also see it as y prime is equal to the derivative of f of g of x. So I leave my inside function inside the derivative of f, and then I multiply by the derivative of the inside function. That's what's happening. The derivative of the outer function first. Leave the inner function. And then we multiply by the derivative of the inner function. That's what's happening here. That is the chain rule. We're going to do a lot of practice with this. So I have several examples. I'm going to start with sine of 3x plus 5. I want you to practice identifying the inner function and the outer function so that we follow the right pattern and take our derivatives. Inner functions are typically inside some sort of set of parentheses or other grouping symbols like a square root. Look for those kinds of things. So here, I do see a set of parentheses, and it's around 3x plus 5. So I'm going to say that 3x plus 5 is my inner function. My inner function is g, which would make what's outside of it, sine, my outer function. All right, so to take my derivative, I'm told to start with the derivative of the outer function first. So the derivative of sine, it's cosine. Okay, now it's just not cosine of x, it's cosine of g of x. And remember, g of x is what's inside of my outer function. So what's inside of my outer function is 3x plus 5. So cosine, derivative of sine, leave the inside alone. And then we're told to multiply with the derivative of the inner function. So now we're going to multiply that with the derivative of 3x plus 5. And that's going to give us 3. Now in terms of cleaning that up, really I could just move the 3 to the front and be done. The 3 cosine of 3x plus 5. Okay. So second example, y is equal to x squared plus 1 cubed. Now any set of parentheses should alert me to an inner function. So I'm going to say that x squared plus 1 is my inner function. Let's call it u. So if I do that, this becomes u to the power 3. And so what happens is, now this is my outer function, because I really didn't see anything in front of x squared plus 1, so there won't always be, like there was a sign. Sometimes it's something else, like an exponent. So it's this power, and that's going to be our outer function, the power rule. So let's label that. This is our outer function. We're going to start by taking the derivative of the outer function first. We always want to do our outer function. So, and let's just leave it in terms of u for now. Okay? So we'll kind of look at it as if we're using the first definition I gave you. So the derivative of y with respect to u. So instead of x's, we have u's. U cubed has a derivative. Use our power rule. We get 3u squared. Okay? So that's my outer function's derivative, and then I want to multiply it with the derivative of my inner function. So my inner function is x squared plus 1, so its derivative is 2x. Well, I can't leave my answer like this because I'm taking the derivative overall with respect to x. So I need to finish by having all x's back in my function. So we just have to do a little bit of substitution. So what was u? So back in place of u, this is now 3 times the quantity of something squared. So that something is u, and u, the inner term, was x squared plus 1. So we're just going to plug that back in. And then we're going to bring down our times to x. We were able to go ahead and multiply that 3 and 2 together, and I'll go ahead and bring the x to the front. So my final simplified answer is x times x squared plus 1 squared. Let's go back. We don't have to use the substitution like I did here to take our derivative. But once you've narrowed down what the inner function is, and then you kind of cover that up, you notice that the power rule is what's left, u cubed, or something cubed. So my outer function is just the power rule. We bring down 3, and we drop the power by 1 to a 2. What was inside, remember that inside function, g of x? You leave that inner function, and that inner function, x squared plus 1, just stays inside. So again, we bring down the 3, we drop the power by 1, we leave what's inside, inside. Then we multiply by the derivative of that inside term. Okay, and simplify. So you can kind of skip this step here. So let's move on to example 3. So we're going to practice that without having to do the rewrite. So you'll notice your inner function is x squared plus 3x plus 4. This is my inner function. Then the outer function is something cubed, just like last time, something cubed. So when we take our derivative, we start with the outer function, which is the something cubed. We do our power rule. We bring down 3 and drop the power by 1. So 3, drop the power by 1. Remember what was inside stays inside. So this carries down. And then our last step is to multiply by the derivative of what's inside, or by the inner function's derivative. So derivative there would be 2x plus 3. Not much you can do to clean that up, so that's going to be it for our derivative. Right, number 4. So here is the first time we've come across a square root. So I told you got to look for grouping symbols. Parentheses is one type of grouping symbol, but a square root function works as another type of grouping symbol. So my inner function is what's inside the square root function. So x cubed minus 2 is my inner function. And if I replace that with u, you'll notice we're left with the square root of u, or u to the 1/2. Okay, so we can write that either way. We're going to go ahead and write it as u to the 1/2. And this then is my outer function. So again, I'm going to repeat like I did with number 2 using that substitution method to help us kind of see the derivative, and then we'll try to practice without using it as well. So my derivative, we start with the derivative of the outer function. So I bring the 1/2 down and drop the power by 1. So 1/2 times u to the power negative 1/2. Right? And then we multiply by the derivative of the inner function. So the derivative of x cubed minus 2 would be 3x squared. We've taken the derivative, but we have some cleanup and some substitution to do. So we don't want to leave u in our answer. We need it to be all x's. Okay, so we're going to go back and substitute what was u. So u was x cubed minus 2. So I want to make sure I plug that back in. One half of something to the power negative 1/2. And that something was x cubed minus 2. And then, of course, we want to bring down that times 3x squared. Right? And then we need to simplify some more. So we're not supposed to leave negative exponents in our final answer. We do need to move this term down to the denominator, which puts it next to the 2 here. So 2 times, well, it's going to be x cubed minus 2 to the power positive 1/2 when we move it down. And a power of 1/2 is the same thing as a square root. So I could also write it as a square root of x cubed minus 2. And then we'll just bring that times 3x squared over here to the top. So there's my derivative. No, we don't need to rationalize that. Just starts getting messy if we do that. So next problem. We're going to do tangent squared of 3x. So this is when we start getting a little bit tricky. Tangent squared means tangent times tangent. If I wrote it that way, I would use the product rule to take the derivative. Tangent times tangent would require product rule. In order to bypass the product rule, what we need to do is rewrite this the correct way. So this is just shorthand notation, how we write the 2 here in the middle. But it's actually tangent of 3x quantity squared. So this is the way we need to start with trig functions that have higher powers. We always need to rewrite them first. I'm going to make a note here. Always rewrite trig functions. So what I mean is, if there's a power here and it's not a 1, but if it's a 2 or a 3 or a 5/2, you're always going to rewrite it on the outside. All right, so the reason we're doing that is because this function gets a little complicated here. So looking at grouping symbols, you'll notice there's two sets of grouping symbols. We have parentheses, and then we have a set of brackets, which means we actually have not just an f of x and an inner function g of x, but also a third inner function h of x. So we have the innermost function, 3 of x. So he's way at the end, innermost. Okay, now what is 3x inside of? Well, it's inside of tangent. So that means that tangent becomes the next inner function. And then what is tangent inside of? Well, it's inside of a set of brackets here. And if I cover up tangent 3x, I'm left with u squared. So I'm left with that power rule again. Okay, so my outer function is going to be that u squared. And that's what we start with, the derivative of u squared. Then we do our inner function tangent's derivative. Then we do the derivative of the innermost function, 3x. It just keeps going and going, and this could happen a lot more, but it probably won't. So in our derivative here, we start with the derivative of u squared, which we just need the power rule. We get 2u to the power 1. So 2u to the power 1. And you don't have to write the 1, but I'm going to skip on writing u. Now u is what's inside. So u is what I kind of grouped here. So ignoring the power, the 2, u would be everything else. So u is everything underneath that power 2. So u is tangent of 3x. So that's my outer derivative, leaving all of the insides alone, all of it. Okay, so that just carries down. Then it says, the chain rule says, multiply by the derivative of what's inside. So the next inner function is tangent. Okay, and the derivative of tangent, we go back up to the top. The derivative of tangent is going to give us, or I'm sorry, if we go back to objective 5, we'll see our derivative of tangent is secant squared. Remember, it's not just secant squared of x. Since we're doing the derivative of tangent 3x, that inner function 3x has to stay here. So secant squared of x. Okay. And the last thing is to multiply by the derivative of the innermost function. So the derivative of 3x is 3. So cleaning that up, all I see really is that I can combine 2 times 3. Okay, I can't push the tangent and secant squared together, so those are going to stay as separate terms. So my final derivative, we have 6 tangent 3x times secant squared 3x. So here is number 6. We're going to do another one of those trig functions. So I have cosecant squared of 4x. Right, so anytime we have a trig function with a power that's not 1, we have to rewrite it first in order to take the derivative, or at least until you really get the hang of this. So cosecant of 4x quantity squared. The very last function we'll take the derivative of is the 4x. Outside of that is the cosecant term. And the first function we'll start with is our u squared. So our power rule is going to start off the process here. So that u squared derivative, we bring down 2 and drop the power by 1. So 2 times something to the power 1. So what was inside stays inside. So cosecant 4x comes down. All right, moving on to the next one. We multiply by the derivative of cosecant. So remember, anything that starts with a C, our derivative is negative. And the derivative of cosecant is cosecant times cotangent. And I want to remind you, what's inside for x stays inside. So this isn't negative cosecant x, cotangent x. It's negative cosecant 4x times cotangent 4x. Okay. Then we move on and do the derivative of 4x is 4. Okay. So outer function derivative, power rule. Inside of that, trig function derivative. Inside of that, derivative of 4x is 4. So to simplify this, we'll multiply 2, 4, and the negative, so negative 8. Notice I have cosecant 4x times cosecant 4x. So I'm going to rewrite those together as cosecant squared of 4x. And last times cotangent of 4x. Our answer there. And number 7, I'm going to work with a fraction here. I'm going to take the derivative. We're going to need the quotient rule, since we can't simplify this division first. So again, because I have an x term divided by another x term, and I can't do that division of x's first, I have to use the quotient rule. So you'll remember the quotient rule is low d high, so the derivative of x is 1, minus high x d low. So here we go. To take the derivative of 1 minus x quantity squared, instead of multiplying it all out first, we can use the chain rule. So 1 minus x is the inner function. So this is our inner function. We'll do its derivative last. And it's inside of u squared. So to take the derivative of u squared, we'll start with our power rule. We'll bring 2 down out front, and we'll drop the power by 1. So times 2 quantity to the power 1. So power rule first, times the derivative of what's inside. So now the derivative of 1 minus x. So that's going to give us times negative 1. So what was inside here? What's the inner term? The inner term was 1 minus x. That goes here. And now we've done our low d high minus high d low using the chain rule all over the square of what's below. So we're just going to write that as 1 minus x to the 4th power. All right, so now it's a matter of cleaning up. So you have a good amount here on top to clean up. We could factor out a 1 minus x from both terms, so I'm going to do that there. Both of these have a 1 minus x. So if I've done that, I'm left with one more 1 minus x. And over here, if this term is gone, we're left with a plus 2x. So that cleans up really nicely. All over 1 minus x to the 4th power. Right. Adding together our like terms here, negative x plus 2x. So we're going to have 1 minus x times 1 plus x over 1 minus x to the 4th power. And then we can reduce. So 1 here with 1 here, leaving 3 behind. And my final answer, we have 1 plus x, or x plus 1, over 1 minus x cubed. One more problem to go, number 8. X squared times the square root of 1 minus x squared. So we have two variables in here. We have our x squared term and x squared here under the root. And it's not possible to actually do that multiplication first of the two things together, which means to start this problem, we need the product rule. So we're going to pick out term 1 and term 2. And the chain rule will just come up when we get to one of the terms. So the derivative here, we start with the first times the derivative of the second. Take the derivative of the second term here. Notice the square root acts as our grouping symbol. And so we have our inner function 1 minus x squared. And then our outer function is the square root function. So again, we have 1 minus x squared is our inner function, which would leave then root u, or u to the power 1/2, as the outer function. That right there is going to be our outer function. That's what we start with. So we start with the derivative of u to the 1/2. So we do our power rule. We're going to bring 1/2 down and drop the power by 1. So 1/2 times u to the power negative 1/2. So I don't want to write u, I want to write what was u. U was the inner function 1 minus x squared. I'm going to leave that. Okay, and that's the outer function's derivative, leaving the inside alone. Then we want to multiply by the derivative of what's inside. So the derivative of 1 minus x squared is negative 2x. All right, so let's go back to what we were doing. We were taking the product rule, and all we've done so far is 1 d2. So this is the first times the derivative of the second using the chain rule. But we still need to finish. So plus the second term, which is root 1 minus x squared, times the derivative of the first term. So that's going to give us 2x. So we've done the derivative. Now it's just a matter of some cleanup. So I've got 2 divided by 2. I'm going to reduce those. We can put the x times x squared together, but it also has a negative out front, so I don't want to forget that. So I have negative x cubed in the numerator. And then this term needs to move to the denominator to make that power positive. Okay, and a power of positive 1/2 is the same thing as saying a square root. And that's it. That's my first term. Over here we have plus 2x times the square root of 1 minus x squared. Problem? Let's get a common denominator and put the two terms together. So that common denominator is going to be the root of 1 minus x squared. Our first fraction already has the common denominator. The second one does not. So here we're going to multiply in our second fraction. Root 1 minus x squared on the top and the bottom. So what does that bring down for us? Negative x cubed plus 2x times, these two terms multiply together, we just get 1 minus x squared. 1 minus x squared. Alright, so let's clean this up. We need to distribute the 2x and add together our like terms. So that's going to give us a 2x, then minus 2x cubed. So negative x cubed minus 2x cubed are like terms. That's going to add up to negative 3x cubed. So I have 2x minus 3x cubed all over the root of 1 minus x squared. So even if I factor out an x up here as a DCF, it's going to leave me with 2 minus 3x squared. Nothing that I can do to simplify this, and again, we do not need to rationalize. So this is our final answer.